Welcome to this video on pointers, which will demonstrate a simple program based on pointers in C. Before we begin, let us revise the concept of a pointer in C. We know that a pointer is a special memory variable which can store the address of another variable. So if I have different variables in my programs like n and m, so you see here two variables in the program, n and m. N is an integer, the type of n is int, while m is of type float. With these values, and given in brackets are the memory addresses of n and m respectively. We can store the addresses of n and m into special variables which will point to these locations. So for example, we can create a variable pn which will be a pointer to type int, which can store the address of n. Similarly, we can create another pointer variable pm which will store the memory address of m. So you can see here that pn and pm are pointer variables. They have their respective addresses. So pm is having address 4000, pn is having address 5000. pm is pointing to m, that means it contains the address of this memory location m. Similarly, pn is pointing to n, that is, it is storing the address of memory location n. We can summarize this as follows. If I write the expression pm, it is translated to address of m, which gives the address of m, that is 1000. You also have one more operator for accessing the values which are stored in the variables through a pointer. So if you want to access this value of m, that is 3.5, via pm, via this pointer pm, you can do this using the dereferencing operator, that is the asterisk symbol. So if I write the expression star pm somewhere in my program, then this expression translates to star of address of pm. That means you replace this pm by what actually it is, that is nothing but address of m. Now star and address of, these are complementary operators, so you are left with only m. So they cancel each out and you are left with only m. So in effect, when you write this expression star pm, you extract the value which is stored at the address which is pointed to by pm. That means if you want to access the value of m, you can either write the expression m or you can write the expression star pm, as pm is a pointer which is pointing to m. The same logic goes for the variable n. So if you write star pn, you will get the value which is stored at location n, that is 5. Now coming back to the program, let us quickly see how we can validate whatever we have seen so far by running a simple C program involving pointers. So in this program, we will have our variables n and m. So n was of type int and m was of type float. Now we will create two different pointers, one of type int to point to n, the other of type float to point to m. So we will call the pointers pm and pn respectively. Once we do this, we will simply print out the values of n and m respectively using the printf statement. So when we say %d, %f and write n and m respectively, we will be able to print the values of n and m. These values of n and m we can initialize here itself. So I am initializing n to 5 and m to 2.5 in this program. Now, so my n is equal to, I'll write this expression, and m is equal to this on a new line. The next thing that you can try out is printing the addresses of these variables. So we already know that the addresses of these variables can be printed out using the expression address of n and address of m respectively. So the addresses are pointer types, so we will use %p as the format specifier. Now this same thing, so here you are using the address of operator. The same thing we can print using the pointer operator. Okay, the pointer. So what we will do here is we will simply say star pm and pn. So when you write pn and pm instead of address of n and address of m, you will get the addresses of n and m respectively printed. But this will happen only if you do the proper assignment, which you have not done so far. So we have not done this assignment. We have not assigned these pointer variables to some address. So let us do that first. So what we will do is we will say pn is equal to address of n, and we will say pm is equal to address of m. Once we do this, we can safely print this addresses, because if we don't do this assignment, the pointers have been declared in memory, but they are containing garbage values. You have not assigned any value to these pointers, so they are not pointing to any valid memory addresses. So this assignment step is very important before you try to use the pointers later on. Now the same thing that we saw in the earlier demonstration, that if you want to print the values of n and m via the pointer variables, you can do that using the dereferencing operator. So we will use the dereferencing operator. So this will remain same, but these expressions instead of n and m, we will use star pn and star pm. Let us put our return 0. Now that we have written this program, we can run this and check whether we are getting the same addresses for same outputs for these two lines, that is the address of n and m, and the same output for line number 11 and line number 14. So let us run this program. So I am in the directory where I have saved this program. The program name is pointers1.c. So we will just use GCC and run it. So we say GCC pointers1.c, press enter, waiting for it to compile. So once it is compiled without any errors or warnings. You can run the program using A, because the operating system that is there on this laptop is Windows, I'll simply say A. Okay, so now we see that we get our output. The first line and the fourth line matches, and the second and third line matches. So which is proving to you that now the pointers Pn and Pm are indeed containing the addresses of N and M. And since they are containing those addresses, you can print out the values which are saved at those addresses using the dereferencing operators via the pointers. So that's all for this video. See you next time with yet another video based on more examples on pointers. Thank you.